Hello dear students. Today we will be discussing about two topics: photoconductive cell or photoconductive transducer and photovoltaic cell. So first we'll move on to photoconductive cell. So photoconductive cell or a photoelectric transducer has a photosensitive element which is able to eject the electrons when light falls on it. So it is basically a two-terminal semiconductor whose resistance varies according to the intensity of the incident light. So these are also known as light dependent resistors, and these are also called photoelectric transducer. So basically, once the light falls on the semiconductor material, it is able to release the electrons by overcoming the barrier potential, and based on that the resistance reduces and it is able to conduct more freely. Now the materials that are generally used are cadmium sulfide and cadmium selenide. How do you construct this particular element? For that we need a ceramic substrate on which we are placing this layer of photoconductive material. Then you need metal electrodes to connect the device to the circuit, and the entire setup is enclosed in a moisture resistant enclosure. And this is a circuit simple for a photoconductive cell. Here you can see that a resistance is being indicated and the wavelength of the light is also shown. So this is basically a photoresistor. Now what is the construction? So the light sensitive material, that is cadmium sulfide material, is arranged in the form of a long strip which is in zigzag manner over the ceramic base. It is also given protective sides. So glass or plastic is used as a cover at the top, and the two ends are brought out using metal pins or connecting pins which can be connected to the circuit. Now what is the characteristics? We'll look at it. So you can see that the resistance is the dependent quantity. So we are trying to understand how the resistance varies with respect to illumination or luminous intensity. Now you are defining resistance known as dark resistance. So this is the resistance of the LDR or the sensor when it is not illuminated. So once it is not illuminated, the resistance is very high and it is in the range of 1000 kilo ohms. And once the cell is illuminated, the resistance falls to a few hundred ohms. So here we have 1 lumens per meter square, and the resistance has reduced. So earlier it was very high value, then it has reduced to this value. Okay, and then once with the increase in the illumination, resistance falls to lower values. So you can see that the resistance is directly related to the level of illumination, so that your current can be adjusted with the controlling the illumination. So this is one of the application of photoconductive cell, where you are making use of this cell to control the relay current. Now this, one thing that you need to understand is that always we need an external source of external supply to send the current through this particular circuit. Even if it is a photoconductive cell, only it is a resistive element, only the resistance reduces, it is a passive element. You need an external circuit to set current in this particular material. Now once the cell is illuminated, resistance is low, and once the circuit is complete, some current flows, and once the current flows, this relay circuit will be activated. And once the illumination is reduced, the resistance increases and the current reduces, and accordingly the relay control current also reduces. An external resistance R is also provided to limit the current through this particular circuit, because you only have the resistance of the photoconductive cell which will be in terms of few hundred ohms. So you have to limit the current through this relay circuit, so you are using an external resistance R also. Now this is a voltage divider circuit using LDR. So here you can see that an input voltage is given, and you are dividing the input voltage into among two resistors. One is an LDR light detecting resistor or the photoconductive resistor, and the other one is a normal resistor. So we are measuring the voltage across this R2. So you can see that using this equation, V out is equal to V in into R2 by R LDR, which is resistance of the LDR plus R2. So depending on the intensity of the light that is falling, the output voltage varies. So if you need to measure the light intensity, it can be measured in terms of RLDR. RLDR is unknown factor, R2 is known, V input is known, and V out is being measured. So you will get the value of RLDR. Once you get the value of RLDR, it can be the measurement can be calibrated in terms of light intensity. So this is one calibration curve that you can think of. Like you get a resistance value, you plot it, and you get the value of illumination. So that way you are able to find out the illumination. Or rather, you can simply use by varying the light intensity to control the output voltage. So it can be used as an output controller as well as in order to identify the intensity of the light. So in both ways it can be used. Next we'll move on to photovoltaic cell. Okay, so photovoltaic cell forms a basic unit for a solar panel. So this is a basic unit that forms the larger panel. Now photovoltaic cell, it seems very similar to the photoconductive cell, but with a slight difference. In photoconductive cell there is no generation of voltage, rather the resistance is reduced. It's a passive element. But here in photovoltaic cell you have a photovoltage generated. Okay, you have a voltage generated, and that voltage will be depending on the amount of intensity of light that is falling, or amount of absorption of radiation that falls on the junction. Again, this is a semiconductor device. It has two layers, N and P, which are brought together, and you have a depletion region. And once the light falls on it, some of the charge carriers or majority charge carriers move to the conduction band, and the accumulation causes some voltage. So we'll see in detail. Okay, so we have a depletion region and you have some light falling on it, and once the light falls, some of the elements that are present here, or atoms that are present here, absorbs the energy, and it overcomes the barrier potential and move to the conduction band. And once it moves to the conduction band, more charge carriers accumulate near the depletion region, and what happens is that it results in the reduction in the width of the depletion region, and you will have electric field also applied. So during this process, once the charge carrier accumulates in both the sides of the depletion region, you will have some voltage generated. So that voltage is known as photovoltage, and based on the photovoltage you will have some electric field created, and the entire process causes more electrons to be ejected, and you will have more electrons or majority charge carriers to be ejected in both the regions, and ultimately you will have a current flow once the depletion region is completely removed. So this is the entire working. You will have some electron hole pairs being formed on either side of the peer junction. So you will have some holes and electrons accumulating in the P and N sides, and the excess majority carriers that are produced by this process causes the voltage to rise in both the regions, which is known as the photovoltage. So once a voltage is there, once you connect this particular cell with the external circuit or with a resistive circuit, you will have some current flowing. Now the difference between a photoconductive resistor and a photovoltaic cell is that here you have a voltage generated, just like in a normal diode. This is it works very similar to a diode. The only thing is that you are not supplying any external source of energy for the photovoltaic cell. Rather, the energy is the light intensity that is there, or the radiation that is there. So this is a circuit symbol for photovoltaic cell. So the circuit symbol is very similar to diode, with light falling on the diode. So by absorbing the radiation, you will have an increase in the charge carriers, and the charge carriers accumulate to provide some voltage across the junction, and that voltage causes some current to flow once the circuit is complete. So that is the basic working of photovoltaic cell. Now we'll look at the output characteristics of voltage characteristics of photovoltaic cell. Now with the light intensity, which is measured in lux, light intensity increases, the output voltage produced also increases, and generally without any external biasing, or without any external source of energy or a battery, the photovoltaic cell is able to generate voltage close to 0.5 in the range to 0.6. So this is the voltage that a single photovoltaic cell can generate once it is illuminated with some solar radiation. Now if we need to generate more voltage, you can connect a number of photovoltaic cells in series, so that you are able to get more voltage. You add up add up the voltage of each individual unit, you will get higher voltage levels. And we look at the output current characteristics. So with the increase in intensity of the light, again measured in lux, and this is in microamperes. Remember, the voltage was in terms of, this was in volts. You are able to get in this range 0.5 to 0.6. Here the current is in microamperes. So only very small value of current is flowing with the change in intensity. Now the output current depends on the intensity of the radiation that is there, incident radiation, the size of the cell structure, that is, you are able to create different types of cell structure based on different manufacturing processes. So the output current also depends on that, and also the conversion efficiency of this particular solar cell. Now the conversion efficiency also depends on the spectral content as well as the illumination. Okay, how much this particular cell is able to convert from from light energy to electrical energy. So that conversion efficiency also depends on the illumination as well as the spectral content. What is the content of different wavelengths available, red, blue, etc. wavelengths which are available in electromagnetic radiation. Now you are able to increase the current. If you need to get more current, you can connect different cells in parallel, so that the current capacity increases. Okay, and this resistances which are marked comes from the equivalent circuit, which you may not be requiring right now. So we'll look at that in the future semesters. Now you can understand that the current intensity will be varying with respect to the light that is falling on the cell. So in this way, you are able to detect the amount of light that is falling by looking at the voltage, okay, as well as the current. You measure the voltage across it, and that can be related to the intensity of light. So it can be acting as a sensor which identifies the current and acts accordingly. Again, this photovoltaic cell as well as photoconductive cell, both are termed or classified under transducers. So transducers are devices which convert one form of energy to another. Okay, so that is the idea of transducers. So these are all transducers. So whatever we have learned today are transducers that convert electrical energy to light energy to electrical energy. So by looking at the output voltage and output current, you are able to predict the light that is, or you are able to indicate the light that is falling on the device. Thank you so much.